So let's get started. We're going to start over here. I'm going to zoom in just a little bit. So when we say free fall, we're talking about an object that is falling when it's under only the influence of gravity, okay? That means that it has only gravity acting on it. So if we were to draw a force diagram, it would have one arrow, and that would be gravity. Anything that's in free fall has the same acceleration. All things, it doesn't matter how big or small it is or what shape it is, it's all the same acceleration. How is that even possible? Well, let's look at Newton's second law, okay? So remember, Newton's second law says that A equals F net over M in an equation. And since it's only got gravity acting on it, the net force is the force of gravity. So I've replaced it with Fg. Now, we learned in, let's see, lesson 2 of this unit that the force of gravity is m times g, right? Do you remember that one? And you see how we have an m on top and an m on bottom? That means that, whoops, I've erased too much there. That means that we can cross out those two m's, and so that acceleration is actually just g, which is that, let's see, we called it the gravitational field strength before, and now we're going to call it something else as well, but that's at 9.8. This time we call it meters per second squared as the unit instead of newtons per kilogram. That's its value on Earth. It has a different value on other places, but that's okay. That's about 10 meters per second squared. That's an easier number to work with, though, so we can call it 10 meters per second squared sometimes. We also call g acceleration due to gravity. That's another name for it. We talked about that in lesson 2.